It has already passed Jupiter. And the silence coming from every major space agency on Earth right now is the loudest signal I have heard in over 20 years of following this science. What you are about to hear is not theory. It is data, published data, mission data, numbers that were quietly confirmed, then quietly buried beneath a news cycle designed to make you look somewhere else. Just 3 days ago, something moved through the gravitational boundary of the largest planet in our solar system with a level of precision so exact that aerospace engineers who calculate gravity assists for a living have stopped calling it coincidence. This is what they saw. This is what they measured. And this is what nobody has officially said out loud. Let's start with where it is right now. As of today, 3I Atlas is moving outward from Jupiter at over 60 kilometers per second. That is 60,000 meters every second. The coma. The bright cloud of gas and dust that made it visible for months is collapsing. The outgassing is slowing. Whatever this object revealed during its journey through the inner solar system, it is now going quiet. And the timing of that silence is not random. Here is what most mainstream coverage has failed to frame correctly. 3I Atlas was bright, active, and observable for exactly the duration of its inner solar system crossing. It became visible when it needed to be seen, and now it is fading precisely when it no longer needs to be. If you were designing a probe to enter an inhabited solar system, remain detectable during transit, and then disappear during arrival and departure, you would design it to behave exactly like this. Brightness driven by sublimation on approach. Activity maximized at perihelion for optimal observation. A rapid collapse of the coma on exit. And then darkness for the long journey outward. That is not how random ice and rock behave. That is a mission profile. Then came the age study. Just over a week ago, published on the preprint server Research Square. Based on data from the James Webb Space Telescope collected shortly after perihelion, a team of researchers announced a result that should have dominated every major news channel on Earth. The age of 3I Atlas is between 10 billion and 12 billion years. Not a typo. Not a rounding error. 10 to 12 billion years old. The universe itself is about 13.8 billion years old. Our solar system is only about 4.6 billion years old. This object formed in the early epoch of the galaxy, when the first stars were beginning to forge the first heavy elements. Long before our solar system existed. Long before the disk of our sun condensed from its original cloud. And then it traveled. For roughly 10 billion years, it moved through the void between stars, across the galactic disk, through regions of space that no human telescope has ever mapped. And then, precisely at the moment when we developed instruments powerful enough to detect it, and only now, it arrived here. The probability that its arrival just happened to coincide with the narrow window in human history when we gained the ability to observe it, a window of only about 60 years, is so small that it stops being a meaningful explanation. Something else is happening. The isotopic data from the James Webb Space Telescope confirms its age with what can only be described as a chemical birth certificate. The ratio of deuterium to hydrogen is higher than anything ever measured in our solar system. Carbon isotope ratios fall completely outside the known range of any solar system body. These are not measurements that leave room for alternative interpretation. The researchers themselves stated clearly that this object formed at temperatures below 30 Kelvin, in a metal-poor region of the early Milky Way, cold, ancient, from a place that no longer exists in the form it once did. And they used a very specific word. Built. I am keeping that word. I will explain why. Now, let's talk about what Jupiter measured. On March 16th, 2026, 3I Atlas passed Jupiter at a distance of approximately 53.6 million kilometers. That number needs context. Jupiter's Hill sphere, the region where its gravity dominates over the Sun, extends to about 53.5 million kilometers. This object passed within roughly 100,000 kilometers of that boundary. To understand how precise that is, consider this. The entire solar system spans roughly 5 trillion kilometers. The probability that a random object arriving from interstellar space would pass that close to the exact edge of Jupiter's gravitational domain, within such a narrow margin, is not a number any scientist would be comfortable accepting as coincidence. A useful comparison is this. It is like throwing a coin from New York and having it land exactly on the rim of a wine glass in Los Angeles. Not inside the glass. Not beside it. Exactly on the rim. And that level of precision is not just visual. It has consequences. Any object that passes inside Jupiter's Hill sphere is influenced by Jupiter's gravity. Not just the Sun's. Its trajectory is altered in a measurable way. In orbital mechanics, using a planet's gravity to gain speed without being captured is called a gravity assist, also known as a slingshot maneuver. Voyager 1 used it. New Horizons used it. We designed these maneuvers deliberately because the physics allows it. But achieving it requires extraordinary precision. The entry angle must be exact. The velocity must be exact. The position relative to the planet's motion must be exact. 3I Atlas performed this maneuver on the outbound leg of its journey. Not on the way in. Not during approach, where a coincidental alignment might be argued. But after it had already completed its passage through the inner solar system, as if it had already done everything it came here to do, as if it had a destination, as if it needed to leave faster. Now ask yourself this. If this is a natural object, a comet, a random visitor from interstellar space, then who computed that trajectory? Who set the initial conditions 10 billion years ago so that its exit angle would use the largest planet in our system for a gravitational slingshot? Either the laws of physics produced an outcome so precisely tuned that it becomes statistically indistinguishable from intention, or something planned it. I am not choosing that answer for you. I am showing you the numbers. The exit vector is the part no one is discussing publicly. The path of 3I Atlas after its interaction with Jupiter has been projected forward by independent orbital mechanics teams. And that projection does not appear in any public statement from NASA, the European Space Agency, or any other institution. Now, to be clear, the uncertainty in long-range trajectory calculations at interstellar distances is large. Large enough that naming a specific destination would be irresponsible. So I will not do that. But the mathematics does show something else. The forward trajectory does not point toward empty space. The same method used to trace its inbound path backward, toward a region of low metallicity halo stars consistent with a 10 billion year formation environment. When applied forward after the Jupiter assist, produces a vector pointing toward a specific region of the Milky Way. The kind of place where something that formed 10 billion years ago might have come from, or might be going back to. And before you dismiss that, remember this. The outbound trajectory of Voyager 1 was chosen deliberately. We aimed it. We used Jupiter to alter its course. We know exactly which star it will approach in about 40,000 years. And we publish that information openly. But no agency has published a trajectory analysis for the outbound path of 3I Atlas, an object that just performed the same class of maneuver. That silence is a choice. Now let's talk about what the Jupiter system actually measured. The European Space Agency's spacecraft, designed to study Jupiter and its icy moons, was already on its way when 3I Atlas passed through the region. This spacecraft carries a full suite of scientific instruments. The Janus camera, spectrometers, particle detectors, a magnetometer. These are not simple imaging tools. They are research-grade systems built to capture detailed physical data, and they were all pointed at 3I Atlas. The agency confirmed this. They released a single image, a black and white frame from the Janus camera, showing the coma and the bright central region. And then they stopped talking. But that spacecraft also carries instruments specifically designed to detect radio emissions, plasma waves, and electromagnetic signals from objects in the outer solar system. Those instruments were active. They were directed at the object. And yet, there has not been a single statement about what they recorded. No mention in any official release. No preprint papers. No conference summaries. No researcher discussions in public channels. Nothing. And that is not how scientific delays work. When data is delayed, there are usually announcements, expected publication timelines, researchers mentioning ongoing analysis. There is a visible process. Here, there is none of that. There is one image, a faint blur of light, and then a level of institutional silence so complete that it begins to carry its own weight. What comes next is the part that mainstream coverage has almost entirely missed. There is a mission concept currently under active evaluation, a real aerospace proposal, supported by real trajectory calculations, confirming that intercepting 3I Atlas before it becomes unreachable is still technically possible. Using solar sail propulsion, combined with existing launch infrastructure, there is a precisely timed interception window. The orbital mechanics teams that ran the calculations reached a clear conclusion. It can be done. But the window is narrowing. Every day that passes increases the required delta velocity. Every week of delay makes the mission more difficult. And yet, the window still exists right now. No space agency on Earth has announced any decision to act on it. No press conference. No public acknowledgement that this window is open and closing. Not from any country, on any continent. The mission exists on paper. The only thing missing is a decision. And the people who have the data required to justify that decision are the same ones who released a single image from the Jupiter mission, and then went silent. Which brings us to where this object is going next. Saturn. Within months, not years, but months, 3I Atlas will pass through the region of the outer solar system dominated by Saturn. The geometry is not the same kind of precise boundary interactions seen at Jupiter. But it does not need to be. Because Saturn's system is already broadcasting, its moon Enceladus functions, in every measurable sense, as a transmitter. It continuously ejects water vapor, molecular hydrogen, methane, carbon dioxide, and complex organic molecules through geysers at its south pole. These eruptions are driven by hydrothermal processes beneath an ice shell several kilometers thick. The Cassini spacecraft confirmed the presence of molecular hydrogen in these plumes. That is a direct indicator of water interacting with rock at depth. A chemical process associated on Earth with hydrothermal vents that support life. In other words, Enceladus is releasing the chemical signature of a potentially habitable ocean into space. And that signal spreads far beyond the moon itself. It can be detected from hundreds of thousands of kilometers away by sufficiently sensitive instruments. An object moving at 60 kilometers per second through that region would pass directly through this environment. It would be immersed in that chemical signal without needing to adjust its trajectory in any measurable way. There is another detail from Cassini's final mission phase that matters here. Before its deliberate descent into Saturn's atmosphere in 2017, the spacecraft passed through the gap between the rings and the upper cloud layers. During those final orbits, it detected complex organic molecules at concentrations that surprised mission scientists. Results that took 2 full years of post-mission analysis to fully interpret. And even now, they are still being debated. The chemical environment around Saturn is more complex and more active than expected, and 3I Atlas will pass through it within months. It is already going dark. The coma is collapsing. The outgassing is declining. Whatever this object carries, it does not need to maneuver to sample what Enceladus is continuously releasing into space. It only needs to pass through. It collects, and then it carries whatever it has measured back into interstellar space, beyond our reach. What happens next is something we can only observe. We will watch for any unexpected reactivation of the coma as it enters this region. Whether the declining activity shows any sudden change near the most chemically active moon in the outer solar system. So far, the telescopes are watching. Nothing has been announced. And by now, that silence has a familiar shape. Not everything reveals itself from the outside. Some things simply pass through and collect. The chemistry anomaly involving nickel became even more difficult to explain after the age data was confirmed. Here is the problem. The observations from the James Webb Space Telescope show that this object formed in a metal-poor environment in the early galaxy. At that time, heavy elements were rare. The first generations of stars were only beginning to enrich the interstellar medium through stellar nucleosynthesis. Iron and nickel, at the concentrations we see in modern solar system objects, simply did not exist in sufficient quantities to form a comet with the kind of surface chemistry that 3I Atlas is showing. And yet, the spectral data collected before perihelion revealed something unexpected. The coma chemistry showed nickel in ratios associated with industrially processed nickel alloys. More nickel than iron. Ratios consistent with refined materials. Not natural formation. This is not a conflict between uncertain measurements. The isotope data is precise. The coma chemistry data is precise. Together, they describe an object that formed in a metal-poor environment roughly 10 billion years ago, but is now displaying surface chemistry consistent with industrial metallurgy. You cannot have both. Unless something was added later, something containing nickel. Processed nickel. Something that was not present at formation. Something that was placed there afterward. By what or by whom? Hold that question. Because what comes next only makes it harder to ignore. Now consider the methane. Cometary materials evaporate in a predictable sequence as temperature increases. Carbon monoxide is released first, then carbon dioxide, then water. Methane sits at an intermediate level of volatility. It should be released earlier, or at least alongside carbon dioxide. But that is not what was observed. Methane was not detected until after perihelion. It remained hidden, buried beneath layers that only opened under the extreme heat at closest approach to the sun. And when it appeared, it was accompanied by complex organic molecules, carbon compounds associated with biological chemistry. And they were not released gradually. They appeared at an accelerating rate, consistent with a triggered release. Not steady sublimation. This suggests something very specific. An object that was keeping material protected, thermally sealed, preserved, and released only when a precise temperature threshold was reached. That is what a controlled release system does. That is not how comet ice behaves. A professor from Harvard, Avi Loeb, raised this question publicly in peer-reviewed scientific work. Not in casual discussion, but in formal publication. He asked whether the presence of these biological signature organics could indicate life contained within the object. Microorganisms preserved beneath shielding layers for billions of years, protected from cosmic radiation by a structure that behaves more like a container than a random rock, and only released when heated at perihelion. Mainstream scientific media largely dismissed this as speculation. Yet he leads a major research initiative and has published his analysis with full citations and supporting calculations. So ask yourself this: why do credentials stop being taken seriously when the conclusion becomes uncomfortable? The Galileo project collected data during the perihelion phase. In February, Avi Loeb stated that at least one observation from that dataset requires additional verification before it can be published. In Science, even null results are publishable. There is no reason to delay them. Only one type of result requires this level of caution. The kind where the implications are significant enough that absolute certainty is required before speaking. And the fact that the analysis is taking longer this time tells you something. Now consider another detail that is rarely discussed. During its passage through the inner solar system, 3I Atlas experienced non-gravitational accelerations, sideways forces that cannot be fully explained by solar radiation or standard outgassing. And then, after perihelion, those forces dropped off, not gradually, as would be expected if outgassing were simply decreasing with distance from the Sun, but in a pattern more consistent with something being reduced or turned off, like a system that was active and then stopped. A natural process would produce a smooth decay curve, as outgassing gradually decreases with distance from the Sun. But the post-perihelion force data shows something very different. It looks closer to a step function, high during the inner solar system transit, then sharply reduced on exit. That pattern is consistent with a powered mission profile, one that required active maneuvering through the inner system, and then stopped once the exit trajectory was secured. And there is another detail. The outbound path does not show the accumulated deflection that sustained lateral forces should have produced. Those forces were present, and then they stopped. At exactly the right moment. Either an unusual natural process explains this, or something applied those forces intentionally and then shut them down. Now add one more layer. In August 1977, a radio telescope in Ohio detected a narrow band signal from deep space. It was strong enough that the researcher reviewing the data circled it and wrote a single word beside it: wow. The signal lasted 72 seconds. It was never detected again. For 48 years, it remained the strongest candidate for a signal of extraterrestrial origin ever recorded. Then, in 2025, researchers traced the inbound trajectory of 3I Atlas backward. They found that it aligns within 9 degrees of the origin point of that signal. The probability of that alignment occurring by chance is approximately 0.6%. They checked it multiple times. The number remained consistent. Now consider this possibility. What if that signal did not come from a fixed point in space, but from a moving object, a single pulse, transmitted at a specific phase of its approach? In 1977, that object was still traveling through interstellar space. Far from our system, 48 years later, the same object whose trajectory aligns with that signal passed through our solar system. The signal was never repeated, because it only needed to be sent once, not as a continuous transmission, but as a marker, a timestamp, a message that simply said, "We are coming." And yet, the most important part is not the data itself. It is the silence surrounding it. When something truly unexplained appears in astronomy, space agencies do not remain quiet. They hold press conferences. They compete to publish first. They bring attention to the discovery. Before perihelion, 3I Atlas generated hundreds of research papers and coordinated observation campaigns. But after perihelion, something changed. The James Webb Space Telescope observed it. The Jupiter mission pointed its instruments at it. The Galileo project collected data. The age measurements came in. The force behavior changed. The precision of the Jupiter flyby was confirmed, and the number of public statements decreased. Fewer papers, shorter announcements, less explanation. They are saying less now, with more data, than they were saying months ago. With less. Within months, 3I Atlas will cross the orbital distance of Saturn. Within a year, it will pass Uranus. It will reach Neptune by around the year 2030. After that, it will approach the heliopause, the boundary where the solar wind fades and interstellar space begins. Beyond that point, every telescope we have will lose it. The object itself, dark, cold, and up to 12 billion years old, carrying whatever it carries, will disappear into the void between stars. And what will remain? Data, papers, and silence. The universe is about 13.8 billion years old. This object is between 10 and 12 billion years old. Whatever created it, modified it, or sent it has existed in this galaxy for 6 to 8 billion years before Earth even formed. Before the first oceans, before the first microbe, before every civilization, every language, every idea humanity has ever produced. That is roughly 60% of the age of the universe. There is no framework that fully captures what that level of timescale implies. No instrument calibrated to it. No concept that comfortably maps onto what 6 to 8 billion years of uninterrupted existence could produce. And yet, it came here. It made itself visible for exactly as long as it needed to be. It followed a trajectory that, taken as a whole, reads like an itinerary. It used the largest planet in our system as a navigational tool. It shut down its activity on schedule. And it left. And from every institution that had access to the full dataset, not just the image, but the full dataset, the public response has been the same. Silence. That silence is not nothing. It has structure. It has shape. It reflects a decision. And somewhere between what was measured and what has been said, one of the most consequential questions in human history is still sitting there, unspoken, waiting for someone with the authority to say it out loud. Every anomaly described here comes from peer-reviewed research or confirmed mission data. No fabrication. No embellishment. The numbers speak for themselves. And the silence above them is not empty. It has timing. It has pattern. It carries the unmistakable weight of people who know something, but are not yet ready to explain it. At some point, the data will be released. The instrument readings will be published. The analysis will be completed. The remaining pieces will surface. And when they do, they will not quietly fit into the narrative that has been presented so far. Because the story of 3I Atlas did not end at Jupiter. It has only just begun.